Right. Cool, that works. Home. Right. I'm trying to go home. Let me go to my let me go to the channel. Yeah, there you go. I'm such a horrible person trying to navigate Twitch. Alright, and I already noticed a mistake. It's not scene support, where yeah, what are we actually working on today? I didn't plan this out. Alright, so one of the things I want to work is on transform. So I'm guessing we could just yeah, let's not give it a specific title because I don't know right now what I will be working on yet. I have some ideas, but I don't really have a concrete group I can give it to, right? I do kind of want to blanket. It's cold as hell here. Right, so one of the first things I want to do today is work on a transform component. So let me show you in release what we currently have, right? So when it runs, give it a few seconds to build the bounding volume hierarchy. It renders. Okay, give it up more than a few seconds to run the BVH. Right, we can see that we're running some models, right? And you can kind of see in the console that it's running at roughly 30 FPS. Something along those lines. The BVH takes forever to build, but that's okay. Because it's expensive, but it's only done once. So that's a valid trade-off we can make. We could even store them in file, what I think would be worth it. But yeah. We have that, but sorry. We can now see the models. However, it would be nice to be able to move around the models, because even though we can see them, it's very hard to debug what's actually going on without being able to move around. So I think our first priority for now should be to create a transform component. So this can be class name. Yeah. Transform. Include. Yeah, this could be in core, I suppose, as well. I mean, yeah, everything is in core by now. I might have to do some cleaning up on core soon, because everything is in there, but it doesn't really make sense, but whatever. Right, so transform, cool. Then first thing we need to do is fix this file, because Visual Studio does not like it when it's in files. Core, and then transform. Cool. And the second thing is add the namespace, and then move this into the namespace. Right. So we're going to need a glm vec3, a glm vec4, and a glm mat4. Cool. So in public, we will wait a bit. We will first start with the private members. So glm vec3, and this can be m.angle. So this will simply be rotation. Then we have another glm vec3 m.position, and another glm vec3 m.scale. Right. And this is default to 1.f, 1.f. Right. The rest would be 0, 0, 0 by default. However, the position scale, the rotation, position, and scale should be equal to. These should be 0 initialized. These should be 1, because we don't want an object with 0 scale, because that doesn't really make sense. So for the constructor, we want transform. The glm vec3 m.rotation. So this should be a const glm vec3 reference rotation, a const glm vec3 pulse, and a this should be a reference, and a const glm vec3 reference skill. And these are all default initialized, because that makes life a lot easier. This is equal to 0.f, 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 and same with the rotation. And that equals. Right. And then in the CPP, we need to generate the implementation and simply say m dot rotation equals rot, m dot position equals pulse, and m dot scale is scale, right? So that's going to set the variables here. Then we want some functions here, void set position. This is going to take in a glm, const glm vec3, const glm vec3 reference new pulse, then a void translate. This is going to take a const glm vec3 reference translate, and these are all very simple to implement. So this is m.position is equal to new pulse, and the translate is equal to m.position plus equals translate. Then we're going to need another function. We're going to need to be able to recalculate the transform, right? So we need a void recalculate, right? And this will take anything. Did I misspell this? I think I did. Yeah, I did. Okay. There we go. Recalculate. So why do we need to recalculate it? Well, every time we basically change anything in the transform, we would need to change some of the values. And these are not the scale rotation positions, these are actually stored matrices in there that aren't there yet. So this should call recalculate. Same with this. And we're going to need two matrices here, glm mat4 m.transform, and another glm mat4 m.inverse. And this can be glm indented I. Apparently it doesn't recognize it. I think it's in some other header. Anyway. So that's just default initialized. And same in here, we would need to recalculate. Cool. Then we need some more functions. So we need another function called void set rotation. All right, people bothering on Steam. Set rotation, const glm vec3, new rotation, and a void rotate. There. And these are all in radians. And same with these. Right, and this is pretty simple as well. This basically does the same as the other one. So rotation is equal to new rot, and for the rotate, it is m.rotation plus equals rotation, and then recalculate, right? And then we will need two more functions, void void set scale, and a const glm vec3 reference, new scale, and a void scale. So this will take in a const glm vec3 reference, new scale factor. So just a comment here, this multiplies because we're scaling by a factor, right? So m.scale equals new scale, recalculate, and the other ones that is implemented. So scale will be m.scale times equals scale factor. Right, I think this should be most of the basic functions. Oh no, of course we still need to const glm mod4 reference get transform, and this simply returns m.transform return. And with the and then another one, a const glm mod4 reference get inverse, and that returns return m.inverse. Okay, cool. Now for the actual important function, we need to basically implement the recalculate this. So this will actually be our main maths function, right? So let me take a look at how I did in my old Raytracer, because I keep messing up the order of things in this, right? So I could look up the math online again, or I could just cheat how I've done it before, right? Utility. No, where did I'm pretty sure I made it transform. Yeah, I did. Okay. Where did X? Update matrix, right? Right, so we need to glm 4, translation, glm mod 4 rotation, glm mod 4 scale. Right. And I think I can simply do this is equal to a glm. I think there's actually a function for this. So there is the glm translate, I think. Right, matrix transform. So this is in the matrix transform library. So we would need to include glm gtc gtc matrix transform. Right. So this has a glm translate. There we go. And this takes in a glm identity of type glm mod 4 and the m dot location. Sorry, m dot position, right? So this basically translate it from 0, 0, or the identity, so that would be 0, 0, to the position that we set. So that is glm rotate. I think there is, so rotate, right? So this, right, I think we need to do this 3 times, the rotation, if I remember correctly. So, yeah, we need to build 3 rotation matrices, right? So the glm, so this is glm identity, glm mod 4. Then rotation equals glm rotate. And then this takes in a matrix. So that would be rotation. This would be the x-axis, so 1.f, 0.f. I'm building a transform, so building a transform is basically a way to store position, scale, and rotation. And this would allow me to actually, in the near future, have a camera that's able to fly around. So I can actually move objects in the camera around. And this needs the angle. Right. Yeah, it's pretty cool. Right, so I need to do this 2 more times, and this would be y and z, and then 0.f, 1.f, 0, 0, 0, 1. I don't have a donate button, man. I don't really see the point of it yet. No, I don't have that at all yet. I might do that in the future someday, but at the moment I don't have a plan for it yet. I mean, you could still write obscure things in the chat, but I'd rather not have that and be banned from Twitch. That would be not great. Scale. Wait, does this not? Oh, I'm missing a bracket. Cool. So then glm, sorry, m dot transform equals translation times rotation times scale. and then m dot inverse equals glm inverse m dot transform. I think this should work. I believe this is all we really need for the transform, but I'd rather check another transform that some people made, or that I made in another project, or well, I didn't, but a teammate did. But mainly because this is basically the most important thing, right? If this moth is off, it's going to produce a lot of issues. So yeah, it's going to be a pain. I might have to invert these z-axes actually, but that's fine. So in the calculate matrices, that is in this one. It's glm translate, yeah, that's an identity matrix, position times rotation, sure, and scale. What is just identity and scale? Yeah, sure. Yeah, okay, cool. I think this should be fun. You know, I think this should be everything we really need. Oh, I do actually need a const. I mean, how do you mean, Safian? Start at the beginning and work your way up? You mean as in what this code does, or? I mean, we're already printing stuff in the console if we run it. It's not hello world, but it prints something. But yeah, this code I could explain to you if you want. It's not too complicated. The moth behind it is pretty brutal if you actually like want to know how all the matrix stuff works, but the principle behind it is pretty simple. So let me finish this real quick and I can explain this. Return oh wait, why did I make this void? So this should be a const. Not a void. And the, what is it? Const glm vec3, yeah. I get rotation. Right. And we have another one that is here, yeah. I think this should be fine now, yeah. Void. Yeah, right. So the idea behind the transform, right, is it basically encapsulates all the math logic for for the rotation, position, and scale. So in math, we have something, or mathematics, we have something called a matrix. A matrix is 4x4 numbers, or a grid of 4x4 numbers, that basically stores the rotation, scale, and position in them. And it has some clever math properties where you can basically multiply positions and you can basically move them to where they would be by the objects. So they're quite powerful. However, the order of matrix multiplication is not commutative. So if you have this, right, so a plus b, it doesn't matter if you do a plus b or b plus a. same with multiplication. If we do regular numbers, right? So 2 times 3 is the same as 3 times. So 2 times 3 is equal to 3 times 2. These are all like basic math things that are always true, right? So 2 times 3 is 3 times 2. You can swap them around. However, with matrices, A times B is different than B times A. They produce different results. So the order in how you do things is very important. So what you want to do basically with this, with the transform, is to encapsulate this logic so that the user never has to do this. They simply say, hey, I want to set the skill and I want to get the information that's done from it. So this is basically an easy way for the user to not make an issue, make mistakes. And it takes away a lot of logic from that I have to do as well, right? Because I can simply in my code say, oh, I want a moving car. I just want the car to move forward. Just translate it every frame with say 1 times delta time, right? And it would move forward on its own. What would make programming logic much easier. Do I want to make it go in a circle? I would say, hey, move 1 unit forward and rotate 1 unit, and then it would drive in circles, right? So that makes logic much easier. Or I could actually just get logic becomes much easier because it's all contained in this. Now comes the actual fun part, and that is testing it. So for the camera, transform. So first thing I want to do actually is give each model a unique pointer. No, this doesn't have to be a pointer. This can simply be a transform. So actually, I want this bothers me. I want this on the bottom. Oh, and then include core slash a transform. So this simply has a RT transform, transform. Cool. And this can be default initialized. I would be okay with that. So now, you know what, in the main here, right, we can simply, this main is way longer than it should be, but that's okay. So test scene, I want to... Oh no, this is actually a problem. I just realized, right? Because models share a transform. What is that problem? Models are shared. What is fine, however, yeah, sorry. So the underlying data should be shared, but the transform should be individual. So we can have 20 cows, but they all should have a unique transform. So we might have to change how the model. Right. No, I think we could change this. So now this has a yeah, so now we have a SD vector of triangles, right? But we could simply say each model has a Yeah, we could change this. This is not that bad. So we can simply say that this has a shared pointer to triangles. So yeah, awesome, Stefan. Let you you got it. So instead of this owning the triangles, we would rather have a struct. Right. So we would have a struct here with model data. Data. And this would actually contain the triangles, right? Sorry, this would still be in here. And this would contain a yesterday shared pointer to model data. And this would be triangles. Yeah. So return triangles dot triangles. However, I can simply give this the operator as well. Operators, and this, yeah, returns that. And now I think we can do this beautiful syntax. Does that work? No. Oh, yeah, no, that should be fine. Oh wait, this is a. Wait, let me see what the actual error is. That's. Oh, this just needs a dot at the end, right? So why are we complaining? No operator matches the type. Does that work? Yeah, okay, that works. Sure, cool. Yeah, we can just do this, right? And that returns the proper triangle now. Yeah, let's see if that how much that breaks. And then in the resource manager, we don't store models, we store model data. And then this will use model data instead. And yeah. Right, and that will take in model data instead. Cool. And then in here we should move the BVH to here as well. And same with the bounds. Because that's part, yeah, that's based off these, right? So this is the actual information based of the model that we load in. And these, the transformer material is model specific. Right. So resource manager, load model, right. So the build BVH, right. We don't pass in a model, we pass in model data. Model data. I think that's fine. Then we need to change it in here as well. This takes in model data, model data, model data. Right. Any other issues? Yeah. Oh, subdivide info takes it. subdivide info, right, model data. Info.model, or partition results x1 as well. I don't see the model here though. So partition info. That's odd. Oh, the partition function takes, right. Right, that's model data. Cool. Does this break anywhere else? I don't think so. No. Cool. Then in the resource manager, yeah. No. And it should be, oh, this should be model data. So that works now. Yeah, I think this is fine. We can assign with the model, maybe, yeah, sure. Okay, we changed that. Then we do need to go into the main again because we changed this significantly. So this will give us some issues, right? Sure. So we can simply do this. We want a RT model. This is a cow model. Sorry, so let's just call cow1, right? And cow1 dot wait, can I not set the in model? Where did I put the model? Right. So this is called oh, this is model data. This might actually break quite a few things. We'll say cow1 dot model data is equal to resource manager dot load model cow.obj. Cow1 dot material is equal to resource manager dot get resource or get material default. Okay. And then we pass in cow1. Oh, and then we sorry, this should be std shared pointer of RT model of, and this is then cow1. This is std make shared RT model, right? And then this needs to be the arrow, right? Let's go with one model. Yeah, no, this doesn't work. We need to set the cow1 dot material, right? Is red material. That's fine. Let's build this and see where it breaks. What I imagine is about, yeah, a bunch of places. So this is not model, this is model dot model data. Wait, did I misspell this? Model data. Yeah, they should get rid of already like 10 errors. Let's just rebuild again so we get rid of the errors. And we're only left with 2. What makes sense because this should be there. intersects, and this should be then model data. No, wait, BVH needs to be changed. So that still takes in the model, the traverse, right? So BVH this, the traverse BVH, it takes in still a const model. Oh, no, sorry. The traverse takes the model data, but the intersect doesn't. This takes in the raw model. Right, and then this passes in the model data, right? Dot get the reference. Okay. So now this should work. Functions.cost. Resource manager CPP. There is a issue still here. I cannot convert from RT model to model data. Right. Where are we getting this? Oh, wait, right. The Obj Loader. This returns model data already. Right, what is model data? No, I changed that already. No, okay, wait, no. We don't have the Obj Loader. Yeah, it's right here. Right, so this returns model data. Model data. And I think nothing changes here. And oh yeah, this needs to be model data as well. Okay, cool. And then this is of course going to break again. Oh, right, yeah. We just changed this, but then this should be still model. Right. Oh, that was why it was already changed because yeah. And then recompile. And now hopefully we should, yeah, it built successfully. So if we run this, we should now still see the same cow. I did everything correctly. Cool, I did. Ow. Ah, my feet is asleep. Ah. Right, so we still see the cow. Now, we can, in theory, because we have changed it now, so we can do in the while here, where do we calculate the delta time? Oh, right, I think I can just do this, right? So, after everything is done, yeah, we do cow1 dot transform dot translate 1.f 1.f, oh no, sorry, 0.f times delta time. Wait, do I not have a delta time stored? Apparently I don't. Okay, but we can simply do that. So delta time is equal to and then this prints delta time. Right. So now the cow glm fact 3. So now the cow should move forward. Yeah, we did everything well. Oh, yeah, no, wait, yeah. The cow is not going to move forward at all because in the Raytracer I don't take care of it at all. Right. Yeah, no, that makes sense. We need to transform the ray. So in the BVH, in the intersect, we would say ray, we need to get a new ray. So RT ray, this is transformed ray. Right. So the origin, that would be ray.origin times, so we do need to make this a glm vec4, that would be ray.origin, and this would be a position, so we need to do 1.f times model.transform dot why can I not get the, do I not have included the model? Right, did I include transform in here? Yes, I did. Okay. Oops, no, I didn't want to do that. Or was I in the BVH? Right. In the traverse, yeah, so this needs to be, this is interesting. Why can I not get the, oh, they need to be const functions, right? Transform. So the get transform is const. Same with the get inverse and the get scale, get rotation, get position. These are all const. Get position. Oh, good that I found that out. So that's const. Get rotation is const. Get scale is const. Get transform is const, and this is const. Okay. And then model transform dot get transform. Right. And then we have another glm vec4, and this is of type, so this will take ray.direction, comma 0.f, because it's the direction, and then times model dot transform dot get transform, and then we pass in the transformed ray. Right, and now this should actually, oh, my camera is really foggy for some reason. It's not really focusing. Right, that's absolutely perfect. I expected nothing less of my code. I mean, it could actually be moving, right? But it's just moving really, really slowly. Why is my camera not focusing? Let me see if I can have it focus better. Okay, that's horrible. Let me... right, so it's a bit more nuanced than that. Right, yeah, so Breda University has basically three main directions for their programming students. You have engine, graphics, and gameplay. So gameplay is, well, very gameplay focused. Engine is more in the architecture side, and graphics is, well, graphics, so Raytracing, stuff like that. So I think one of the reasons, well, of graphics students are from Breda University is that, for example, in the first year, we're actually tasked with making a Raytracer, like in the second block. So in the after 8 weeks, we have to make a Raytracer from scratch, right? So we enter the education, know barely anything of C++, and then, okay, guys, make a Raytracer. You have 8 weeks, and you're basically thrown in the deep end, and it's all good luck, have fun. Also, all the teachers are actually from the industry, so a lot of teachers have experience with working with graphics as well, so that helps a lot as well, I think. I hope that answers your question, Manu. I am personally more a engine programmer, but I do like graphics as well. I would say I'm somewhere in between. You program as well, man? Or well, yeah. Do you program? Oh, awesome, awesome. Can you talk about it, or is it all like? Wait, you actually work at Unity? Oh, that's awesome. I have actually never used Unity, although I am very interested in it because in our education we're mainly working with Unreal because it uses C++. However, as a programmer, I absolutely despise Unreal. I really don't like working in it. From what I've seen, Unity does provide. Oh, that's awesome. From what I've seen, is that Unity allows a much closer programming basically experience than Unreal. In Unreal, it's like, hey, you have to do this in this specific way. No documentation. Good luck figuring it out right. And that kind of bothers me. And from videos I've seen about Unity, I think there is a guy, I don't remember his name, but he made like a serie where he made like procedurally generated planets. I can probably get his name real quick. Procedural planets. Right, he is called, oh yeah, Sebastian League, right? So he did, yeah, Sebastian League, exactly, yeah. So he made some really cool videos with about procedural generation, and that looks much closer to like real programming than what Unreal offers, in my opinion. Yeah. But again, I've never used it mainly because I've never used C#, right? So it's all very new to me. By the way, thanks for the follow. So the recalculates. Right, now this is actually correct, these values. So why is this not working in the BVH? I am passing this in, right? Yeah. And then we need to do this. I need to wait one frame. That's a pain, because it's going to take forever in. You know what I could actually do? I could cheese this a little bit and simply said, I could just do this at the beginning of the frame, right? Before we actually render, and then simply say times 20, 20.f. Because I just want to know why the transform isn't moving. Or the array isn't being transformed, right? Yeah, thanks, Ben. Thanks, Ben. I will definitely have some fun with this. I like making them. Right, so the transformed ray, the direction. Right, the origin is actually being moved. So why doesn't the cow move? Yeah, because the Z is... No, I think the camera's already on the Z. Interesting. So let me check the transform. The transform is... The X is at 20, right? So why isn't this being moved? Because this is at 1. Because this should be a different value. That's odd. Is the direction any different? So 0.49, 0.49. 0.49 as well. Yeah, and 0.71. That's all minus as well, right? Double checking. Yeah. Okay, interesting. So I'm going to see if I can get my camera to focus. I think it might be having trouble with my window. So I'm going to check if I can fix the gut rays from there that we're seeing. Right, I think they're coming from here, maybe? No. Right, let me see if that helps. Is it my light that's producing this? I think it might actually be my... What? Is it my light? Huh. Or, I think it might be this. Right, that did nothing at all to change it. Okay, that's great. I mean, I could move my camera a little bit. Yeah, sure. No, that's not really better. Oh yeah, it's definitely my actual light. That's great. Yeah, sure. Nothing I can do to fix this. Although I am really curious why the camera is this low res, right? Because it wasn't before. And even on my OBS it looks fine. If I enlarge it, right, it's a bit pixelated, but not as bad as on the stream. So that is peculiar, but whatever. I think I just have to live with it. Can I... Here, let's deactivate it and activate it again. See if that helps. No, that's literally the exact same. Configure video. Camera control. Maybe this is better, 50 Hertz. No, right. That doesn't help at all. Is this any better? No, that's worse. What is... Oh, no, that's the... Right. I tried all the settings, but it doesn't seem to be improving at all. That's kind of frustrating. Could it be simply that it's too dark in my room? I could open the blinds and see if some more light... Oh no, that's worse. If I just do this, like all the light comes in. However, I could do, I think if I keep going, yeah, like we can do a bit more light like this, right? If we have the opposite way. Think like this, yeah. We should have a bit more light in the room now. Right, is that any better? Is my camera now magically focusing? No. Okay. Sure. Whatever. I at this point I give up, right? Because I really don't know why it's doing this. It looks fine on my on the monitoring, right, in OBS. But on here the stream looks... Oh, you know what So okay, when there's something funny. So I've just checked the stream because I've just been focusing on the camera and on the rest of the stream. I just noticed that the rest of the stream looked like absolute garbage as well. So I changed the quality in the stream and it suddenly looks fine. Right, let's not talk about that anymore. So why does this not actually change anything, right? Because this should multiply by something. And the transform is equal to, yeah, this does have a value. Right, what if I switch the order and the deviation of multiplication? Because that can matter. However, I don't see why it would not work. Anyway. Let's see if this helps. I really need to figure out something for the BVH. Right, transformed Ray. Yeah, there we go. Right, so it was the I think it was the multiplication order. I don't know why that. I mean, I know why it makes sense, but it's a shame that GLM doesn't correct for it, right? And then in main, we can change this again, and then instead of, yeah, we don't want to do this here. We want to do this at the very end, just before we calculate delta time. Yeah, so in here, and then we want to multiply by delta time and something small like this, right? And hopefully that should move the cow along now. Oh, give me a second, sorry. I will launch it in release so we can actually see what it's doing. Because I forgot that debug has got awfully slow and takes like 3 years to produce the BVH. That's big. Right. The cow is moving. The only thing I don't know why is why the cow is moving to... No, I do know, right. This is positive, this is negative, right. So it's moving on the positive direction, right. Sure. I mean, this is a bit too slow, right. So we can move this to about 0.06. So they should move a bit faster. There we go. That's some proper movement. But what if instead of that, I simply do now rotate? And I rotate on the axis, and then let's just try 0.1 and see what this does for the rotation. This might spin the cow way too fast, but it might also not. Yeah, that rotates it way too fast. So that needs to be like about, I would say about 0.05. I think that would be roughly a good value for the rotation speed. Yeah, there we go. That looks decent. Although it could actually be a bit slower because I think I'm seeing some issues with the cow. But it's a bit hard to see with this speed. So let's put this to 001 and move the camera a bit closer to, like, say 10. I think that should give us a nice view of the cow and hopefully figure out what the glitching was, right? Right, so there's definitely something wrong with the cow. Let me increase the brightness of the lights so we can see a bit better what's going on. So that's in the main now as well. Yeah, I remember. So the intensity here can be to about 500.f. Same with this one. Oh, 500. That should give us a bit lighter cow, or a bit brighter, so we can see what's going on. Because the darkness of the cow makes it. Yeah, right. Okay, so there is definitely something wrong with the BVH. It looked fine before, but now we can clearly see that there are issues. However, this might be from very easy to fix to nightmare to fix. All right, but at least the transform is working. So let's try something else, because I just kind of still want to tinker around a little bit with the transform to see if everything is working as it should, and then we can debug the cow. So this is on the X and Y. So this should, or like kind of go, yeah, this I think this looks fine. How it should. Yeah, because it rotating. Sorry, it rotates around the Y, so that's this way, and it rotates around the X, so that would be this way. And we have the Z, what would be rotating this way. Yeah, I think that looks fine. But yeah, the BVH is definitely producing some weird artifacts. It looks mostly fine, but there are some issues for sure. Okay, right. Interesting. And I'm pretty sure we had this issue before as well, because if we go back to the Ferrari, right? Let's change this, instead of the cow, to be the Ferrari. The Ferrari had issues as well. Hopefully I can see it a bit better with the rotation now. This PVH will take a bit longer to complete though. Do I still have? No. Oh, okay, yeah, we're not going to be able to see anything. Yeah, the car is too close. And I think the transform of the car is a bit weird in general, but it's a bit hard to see from where we were positioned, because I think the objects are basically in a weird position. Oh yeah, we can clearly see in the car that there are things wrong, but it's doing a really weird orbit. I think it's because it's orbiting around the wheel maybe, but yeah, I think it's the model that's a bit scuffed. But yeah, we can clearly see that we're missing triangles here. This is really satisfying to watch though. Right, so I guess it's time to delve back into the BVH and figure out what's wrong there. But for that, one of the things that would be... Right, let's switch back to the cow and see if I can see why this is happening. Cow. Because this is quite peculiar. And yeah, we can clearly see that there are some object missing. Right, I'm going to be back in 2 seconds while the cow is spinning. I need to put some washing stuff in the dryer. So I'll be back in 2 minutes. Right, I'm back. Right, sorry for the wait, guys. So, yeah, right, the cow. Why is the cow broken? Yeah, that's a good question. So, it looks like the general structure of the cow is actually okay. And I don't think the cow is... or the BVH is clipping, right? With the camera. So it's almost like we're skipping some nodes, producing a wrong result. So one of the things I want to try is, what if we use another model? Maybe that will give us a better insight. So not the Ferrari, because the Ferrari just rotating weirdly. But I do have a potato model as well ready. So that might give us a better vision of what's going wrong. So that's this one. Right, let's see what this does. It's building BVH, right? With this model, it looks not as bad. However, yeah, we need more lighting. So this would be add. This can be still 0. Let's put this one as -5 and this one at 5, and both at position 6 and 4, 4. So now we have a bit lighting on left and the right side. See what that does. Yeah, it's a bit more even lighting, right? And I want another light, actually, that is going to be at position 0. Going to be at 4, sure, and add 0, 0, 4, 0. So that should give us a light like near the camera-ish, lighting the potato from the front. I hope. Yeah, so we can even see what... Why is this still not... so the camera is... the camera's at 1020. So let's put this at 0 as well, and at 20. And, oh, this has some weird light colors. So let's put these all to 1, and put the brightness of this one up by quite a lot. Let's see what this does. Because I'm trying to see if I can get some good lighting, so I can actually debug what's going on, right? Because the... yeah, sure, this will work. Right. So with the potato, it looks like to be happening less. However, it still seems to be happening. Right. We can every now and then, I think, like basically here, yeah, near the top, we can see some artifacts. However, in this part, it now seems fine. And I don't think it's simply the wrong boxes, right? Because you can clearly see it goes, yeah, it happens here and then disappears, but it still keeps the structure. So there is something wrong with the traversal. So in the BVH, right, we have this thing. So if it's less than epsilon, we intersect both. But what if epsilon is a little bit too small? What if we put this value a bit up and see if that helps? No, that doesn't help. Right. So why does this happen? Because one thing I could imagine, right, is that we're skipping some boxes for the thing because we discard them, or whatever, and that produces issues. So let's say if this is greater than, less than, right. So this always happens. I'm kind of curious, does it happen if we brute force the BVH? No. I think it's gone now. Okay, the artifacting is completely gone. Okay. So, okay, I think I know what's happening, right? However, this is quite a big performance hit that we're getting for doing this, because we're still intersecting both things. So let's confirm this again with the cow in the main. All right, so my speculation is what we're doing is if a box is further than another box, and we found a shape already, we skip the box. However, I'm thinking that we're skipping, or skipping is too rough. Yeah, this is looking perfect, right? So what I think happens is, right, yeah, sorry, I'm rumbling. So we're skipping boxes that we shouldn't be skipping, but we can do this a bit more fine-grained, I think. So if we go in both, right, so let's see if we can explain this phenomenon and how we can fix this. So if we simply go into both nodes with the BVH, right? So if we hit both nodes and the distance is less than that, right? So if you hit both boxes and the distance is, so if we just hit both, we go in one of them. If it's different, then we go first on the left and then the right. So the situation apparently occurs when this condition triggers, right? Because only in this, so if we change the statement back again, we will see the artifacting occurring. All right. Now we should have we have the artifacting again. See. So when this happens, when this distance is so very close, let's see if we can debug this. So can we evaluate this? Does this give us an answer? No. Yeah, so these are basically at the same distance. So I think this triggers because this is very small. Right, and then this part triggers potentially. However, can we get a situation where in here where we do have hit left, and so that would be in one of these, right? So if we enter one of these, so the distance right is 0. How is distance right box 0? That should be... Oh. Wait a second. We don't hit right. Yeah, we don't hit the right node. So, why are we even going in there in the first place? Yeah, why are we doing this, right? So we're now going in the right shape. However, this is never going to return anything because we missed the right node. Yeah. Right. You know, let's do this slightly different. So I've hit right. Yeah. Okay. Right. So if we hit left and right, I do kind of want to keep this. Let's just keep this entire part. So else if hit left shape equals traverse BVH. And else if right hit hit right, then this is true. And else, no, we don't. If we don't hit anything, we don't continue, right? Release, go. By the way, Beetle, thank you for the follow, man. I just see this now a bit late, but yeah, thank you. Right, this works. Cool. This seems to be working as it should. So yeah, I think we simply made a logic mistake. This might actually be faster than before as well, but it's a bit hard to test. So let's go back to the potato and see if this now runs as well. Okay, this is actually not as bad as I thought it would be. I'd expected this to be way worse. Because issues with the BVH is usually like actually massive pain and suffering. But no, this seems to be fine. Okay. No, this is fine. Then, you know what I think it's time for? Textures. Textures is going to be simple to implement and fun. So with the potato, I had so let's change it. So we add another folder in the assets. So this would be assets, and then we move in all the assets that we have in assets, and we rename this weird potato name to potato. And I do need to do some slight editing in here. Right, let me put my main screen, my main display, right? So we have this MTL here. But this MTL is going to need some other things. So in the assets folder as well, we want to make a folder called potato. And potato is going to go in here. And it needs the potato, these files. Right. And keep reading, yeah. So this should be potato.mtl. Right. Yeah, go. No, I don't want to download the update. So now if we load the potato, I think tiny obj should give us vertex things as well, right? Load model. Let's see if this works. No. And then not in release and debug. So I can actually debug. Oh, yeah, of course, and this is going to fail immediately because we need to change this to assets/potato/potato.obj. now, right, so there's this. Why does it put the backslash like this? So why is it replacing it with... So you can't find... Oh, wait, did I edited the... I should have edited the file. Are there multiple subjects in this? No. Okay. Wait, let me. This should be an easy fix. So apparently it's still trying to load the... Oh, right. It seems it didn't save for some reason. The OBJ file that I edited. Okay, that's odd. Okay, right. I think... Sure. Okay, whatever. I changed it now again. And now we should see... No errors. Cool. So if we go into materials here, we should see that we have one, and we have the potato JPEG. Sweet. Yeah. Okay. So in material, we're going to need to add something else. Yeah, we're going to have a... No, this is going to be a bit harder. Yeah, let's think about how we want to do this. So first of all, instead of simply doing that, we want to... I suppose we want to load the material from the... However, what I'm kind of thinking about, right, is the MTL loads a material. However, the material isn't stored in the Obj loading. It's stored in yeah. Oh, but what we could do actually is we could store the material in the model data as well, but have this be the loaded in material, so we can still assign it to that if we want to. But the model itself has a separate material. I think that would be better. Yeah. So the material is going to need something. We're going to actually need another library called SDBimage. SDBI. And with SDBI, it will allow us to read images. So go download zip. Right, so let me share my main display again. No, I don't want to share Steam. So in here, we go to depths, and then SDBI, SABI, then downloads, and then we need one file that is SDB image. There we go. And does this automatically work? Include SDBI? No. Okay, we do need to set this up in the property pages. Property pages, all configurations, C++. No, we do have that set up. Right, so this should just work fine. Okay. Sure. So we have a... we need a new file. Add, there's going to be a simple header file, new item, header file, include core. It's going to be in graphics. and this is texture.h. Texture.h. All right. And this would be in namespace RT as well. However, I think we were going to need actually a CPP file as well, I see. Now, because this is going to actually contain some logic as well. New item, C++ file, texture. Right, I misspelled the other file, but that's okay. Graphics. And then go here, texture, rename, texture. So this will include the include PCH. Visual Studio is not doing autocomplete for some reason. That's sweet. Include PCH, include graph. Why are you doing this, Visual Studio? Slash. Right, I'm gonna restart my Visual Studio because this is actually kind of driving me nuts. If it doesn't, yeah, it's just doing tabbing instead of auto completing. Right, so let me restart Visual Studio. Raytracer, cool. There we go. Do we now cooperate Visual Studio? Now IntelliSense doesn't want to work at all. Include now. There we go. Now we actually have IntelliSense working again. Right. That was more effort than it should have been. Oh no, wait a minute. Right. So this should be a class texture. Private variable will be a uint 8 uint 8t pointer pixel array and a uint 32t x. This can just be a glm vec2 size. Right, and this will be m.pixel array. And then in the destructor, we need a texture delete m.pixel array. Then we want a load texture. Load texture. Wait, did I spell this correctly now? I keep messing. Yeah, right, this is spelled correctly. Load texture. And sticks in a const std string ref file path. Right, and then we need to include string as well. Oh, and this will be of type void. Right, so we need to include stbe, stb image, right? Oh, why is the other console still showing? Right. Then with stb image, We need to put this define here. Does this have some example? No. However, I do have it in my old Raytracer, so I can just double check the implementation there. Texture. Image, right? Image width, image height, channels, right? Oh, and then we do need another UN32T, a U32. Yeah, a UN32T. This can just be a short. However, we could just do it's fine. And no channels, right? Then on this load texture, we want to stb set is true to flip it on load, and pixel array equals stb load image file path.cstring. Oh, these are actually not unsigned ints. These are just a oh, right. So these are just called int32. Oh, vec2. I think I can just do type int32. Right, does this not work? I thought I was able to create a vector2 of any type. Sure, you know what we will just do then? No, we can, I think there's a vector.hpp. No, there is not. Wait, there is a way to do this. glm vec2 of type int. Oh, it's just called ifec2. Okay. Yeah, sure. Integer vec2 m.size. Right. And sure. So m.size.x, m.size.y, and I need to pass this in, I think, as a thing, and as a pointer m.channels. Okay, that doesn't work. Why does this not work? And the this would be stbi RGB. Cool. That actually does work. And then in delete, we don't delete this. We do stbi free, image free, and then image or pixel array. And I think pixel array here is just defined as a, in the old one, as an unsigned char, right? What would be a uint8t, right? I think this should be fun. And then we need some other texture, so we want a const uint8 t pointer get texture, and this function is const as well, right? And this simply returns m.pixel array. And then we have a glm ivec2 get size. And then return m.size. Oh, and this needs to be returned as well. Right. And then in the resource manager, no, sorry, in the Obj Loader, we had a material, yeah. So this would include a, this needs to include memory and include graphics, texture.h, right? So this has a SC share pointer, SC share pointer of texture. Right. When we load in now the, oh no, we need to go to the model, and this has a type of material. So this would be an SC share pointer material. This would be loaded in material. Right, so this would just be the material that's loaded in from the MTL file. Yeah. And the resource manager, no, sorry, in the Obj Loader, right, we want to set the right, but a model can have multiple materials. What's kind of a problem because we don't support that currently. Right. Right, what we want to do is, right, we want to pass in the resource manager here. So class resource manager. I want to pass in a resource manager reference resource manager. And we're going to need this to assign and create materials. So for now we can simply do kind of a hack. And then this would pass in this. So the resource manager, we simply say, sorry, in the Obj Loader, if materials dot size, no, sorry, you can just do empty. Model, oh, sorry, if it's empty, model dot loaded in equals resource manager dot, we do need this in here now, so include core / resource manager dot get material default, and else we want to create a new research a new material. So I want to create a material, model, no, sorry, so resource manager dot get material fop off. Yeah, and then this is a art. This is a material. So this is audio material. Right, and then material dot. I do need to include material here as well. Then core slash material. Right, so material dot base color equals materials dot 0 dot. I think it's does it have a I think it's diffuse. Right, and we need to create this as a we need to, because this is a real T array, so we need to create a GLM vector from this. So like this, right? So that sets the base color. Then we want to set the reflective index. And does this exist? So materials add 0 dot re no, this doesn't exist. Cool. So texture dot diffuse text name, right? So this is the diffuse, yeah, so the diffuse texture that we care about. So this texture doesn't exist, right? So we need to add this to the resource manager. So we have another unordered map of STD unordered map STD string and STD shared pointers textures. This is m.textures, and then we forward declare it class textures. No, I think it's just texture. And then a std shared pointer rt texture get texture. Texture name. Right, so we can copy this. So if m.textures text name m.textures texture name, right, and this would be a texture, but we do need to include texture here as well. So I can include core, no, sorry, it should be graphics dot texture. If it doesn't exist, we want to make shared. We don't want to, yeah, we do want to return here. I know we don't want to. So m.textures, yes. m.textures dot texture name dot wait, didn't I have a load in here? I did, right? I have a load texture. Oh, right, this is all considered private. Right. So in here we have a load texture file texture name. or this should be actually falpath, because we're going to use the falpath to the texture as a key. No, sorry. Resource manager, Control KO. So this would be falpath, and then we want to return m.texture, right? And then in the Obj Loader, we want to say, hey, does the texture exist? So, if if material dot zero dot materials dot zero dot diffuse text name does dot empty, if that's false, we have a texture. So check for texture. Check for texture. If that's not empty, then we want to resource manager dot get texture, get base there, falpath plus materials materials dot zero dot diffuse text name, and then material dot texture is equal to this, right? So if we load this in, right, what does this do? Does this magically give me a texture? At least do we load it in, right? Does it give anything in the console? No, that's good. 0. Right, come on. Add to watch. Right, for some reason I can't see it. Oh, right, because this is declared there, right. So I need to get it from the model, right? So pointer loading materials empty. Why is this empty? Oh, right. We need to set the model loaded in material equals material. Right. Of course, it's not going to do anything if we don't assign it. Right. So loaded in material is equal to pointer texture. That's null. Yeah, that's filled. Let's put a breakpoint here. Do we load in a texture? Yeah, we do, right. So let's go inside of this. Yeah, right. So this is assets. Okay, right. We're missing a slash. Okay, so that's easy enough to fix. So that's in the Obj Loader plus slash. Let's see if that does the thing it should. Go in, go out, go in. Falpath, yeah, that's cool. Add out. Sure. So now does the loaded in material? Yeah, there we go. That looks correct. 1024 by 1024, 3 channels. Okay, sure. I'm willing to believe that. I'm willing to believe that's correct. Right. Then in the model data, you have here the triangle list. However, a triangle is going to be extended now. So we're going to have a glm array. Sorry, an std array. Not glm array. What am I talking about? Std array of glm vec3, comma 0, sorry, comma 3, and this is m.texture chords. Yeah. So you need to pass in this as well. When you create a triangle. However, this is equal to 0.f, 0.f. Right, so this is an array, right? glm vec3. No, I think I could just do this and it should be fine. I don't need to actually put numbers in here. Yeah. Oh, and this would be texture chords. Right, and I don't think this works because, yeah, we cannot do it with an initializer list. So we need to pass this as a copy, I think. Initialize. Oh, yeah, and then this, right? No, okay. No, okay, sure. I'd hope that would work. Why does that work? If I do this, glm vec3, do you comply then? Right, no, it's happy. Okay, that's great. It's a bit of a long-winded definition, but I'll take it. And then this needs to be added in here as well. And then m.texture chords equals texture chords. That's right. Then we need here in here as well a const std array of glm vec3, comma 3 reference get texture chords, and this is a const function. Right, and then we return m.texture chords. Cool. So when we load in the model now in the Obj Loader, we should have the, yeah, so this is the attribute, right? So then we want another, we want a glm vec3 oh, right, sorry. This is already one, so we should have a glm vec3 texture and this would be attrib dot vertices. I think we can just copy this, but then instead of this we would need to no, I think we had the attrib dot texture chords, right? And then texture chord indexes. Cool. And then it's vert and texture. And this is not that, this is a That's a shame. Now we need another std vector of type glm vec3 texture, and then texture chords dot pushback texture, and then triangles that push back, and this is vertices. Yeah. Now we have another one, and this is texture chords dot y texture chords dot y plus 1 and texture chords dot y plus 2. Right, so now that reads the texture chords as well. Let's see if this works and not crashes. It crashes, of course it does. Text chords. So how much is this? This is 27, 813. Yeah, that's fine. No, we're getting out of index. Okay. Wait, how does this crash? That's interesting. So this evaluates to, yeah, 27, yeah. Or this one should be fine as well. But this one should be out of bounds. 27, 815, right. However, it crashes on this one. What's interesting? Right, let's and what is the index? Alright, that doesn't quite work. Let's rerun this and see what happens. And put it back, right. So the, yeah, this should be yeah, this is just fine. Yeah, the texture chords is okay, very interesting. Yeah, no, it definitely crashes. Why does it crash? Yeah, I'm guessing it's this line, right? Because this is out of bounds by 1. Is this going to be like plus 0, minus 1? I'm almost tempted to do this, so minus 1. Because I remember something with the indexes being weird, starting at like 1 or something. Yeah, now it's minus 1, of course. The text chord is 0, right? So we would need texture coordinate 0. Okay, this is interesting. Let me consult another project. So in the Obj Loader, right, this doesn't actually use ships. I'm gonna need to dig deep into my code base, because the other Raytracer doesn't have a it has a weird Obj Loader that I don't ever want to touch again. However, I have another project that does have an Obj Loader. Ships that don't load. Space Explorer v2. Get latest. Let's see if this runs now. Yeah, it does, right. Windows project. Oh, it is under core, sure. Model loading. Alright, so how did I read the texture coordinates here? So main display, right? So this is the project I'm talking about. So vertices. Of course! It's not a vec3, it's a vec2. Of course. It's texture coordinates. Yeah, no wonder it's out of bounds. Right. Right, so no model. Yeah, so the triangle, it's not a, it's a vec2 that we're getting. Right, that explains a lot. How could I have not realized that earlier? So just +0 and +1, right? Yeah, and then this is not a vec3, this is a vec2. And then I do need to go back to the model again, or sorry, the triangle, because this doesn't take a vec2 anymore. This takes a vec2. So it doesn't take a vec3, it takes a vec2. Right, there we go. And now we should magically, oh, stop. And now we should magically have a non-crashing code. Okay, now we, oh, and this should be 2 times. 2 times and glm vec2. Perfect. Oh yeah, and this is going to complain as well because this is a vec3. Well, it should be a vec2. How is this not so std array of right, no, this is you know, these are glm vec. Oh, there's an yeah, std array of. Right, is this still in the triangle then? Triangle. Yeah, sorry, it's type vec2. And it's a glm. Oh, no. It's a glm. No, it is of size 3. However, it's a glm vec2 that we're passing in. So this is still size 3, but it's a vec2. And it is of size 3. So this is still size 3, but this is a vec2. Right. Yeah, this should be fine. Oh, and then it's a, yeah, there we go. So it's a GLM vec2 texture coordinates of GLM. And this is of size 3. I'm really not making my life easy here. And then this is a GLM vec2 of size, yeah. And the Obj Loader. This would need another one. What would be texture chords y plus plus 3. Right. And this is fine though. Right. Yeah. Okay. So now they should compile fine without issues. And we should have a array of texture coordinates, right? Yeah, cool. And this runs fine, I'm guessing no. Right, but I'm guessing this is a simple, oh, yeah. That's a simple mistake. That's, it should be +2 instead of +3, right? And then a breakpoint here. But I think I'm already too late. Yeah, I'm already too late. Yeah. So this pointer, triangles. Yeah, we have texture chords now. Cool. Now we need to apply the color of the triangle, right? So if there is a texture, so we want a in the triangle H, we want to get basically want to get color, right? No, wait, sorry. In the model. No, that won't work. Right, now I do need to figure out how to use the UV coordinates again. So I think I need the intersection points, and then, yeah. No, not this one. It's this one. Right. So let me double check my old code. So there is the get color, what takes an intersection points. No. Okay, that doesn't work. Because I think I had texturing supported in the old one. So right, so get UV coordinates. Right, okay, so we get an intersection point, and then we calculate where on the triangle that is, and then we can say that's the UV coordinate. Oh, yeah, okay, right. No, I think I can do this, right? So we get intersection points, see how much percentage of A, B, and C it is, and then we know the actual UV coordinates, right? Yeah, sure. So this would be in material, I'm guessing. Do I want this in here? Because we need some place where we can basically get the texture color, right? Where can I get the texture color easily from? Because this would, I would always say this is in the texture. However, it doesn't make sense because we would still need the UV coordinates, right? So what we could do instead is yeah, I think the best place would be in the model. So we would need a function that basically takes in the UV coordinate ratio. So we would want something like a GLM U8 vec3 get color. So get texture. A would pass in a yesterday shared pointer with the material, then a intersection point, so glm vec3, sorry, this should be a reference, const glm vec3 intersection point, and a const rt triangle reference triangle, and this function should be const as well. So when you get the texture, right, we simply say, hey, the intersection point would be, how do I calculate this, right? So triangle APC area. Right. But how do I calculate the U and the V? Oh, right. So column is, yeah, but that doesn't tell me how. Right, but we could do this in the intersection, but that wouldn't be ideal. So the U and the V is calculated here. Right, okay. So we have a W component as well, but we don't use that. Right. So where do we set the UV coordinates? Yeah, so SketchUp pixel distors I'm using for some information. They basically intertwine the intersection with calculating the UV coordinates. What is cool and all, but we can't really do that because not all models might have a texture. So we kind of need to calculate it here. However, we can calculate the U and the V differently. So we need to calculate the area of a bunch of points. Right. So we need right. So GLM. No, sorry. This is just a float. This is float. Right. So for the float U is equal to. All right. We need so we have float area CAP, and that is equal to area CAP, and that is equal to GLM distance, I think, B minus, sorry, so that would be triangle dot 1 minus hit point, so intersection point, the minus intersection point, right, times how do I get that? Oh, right. Sorry, I'm using the wrong formula immediately. So that is is that just the length, or is that the, right, so I'm here, so it's V, oh, it's just minus, right, okay. Right, so it's triangle dot 1 minus intersection points, and then we do GLM cross. We need to cross this and V so ABC. Right, so this, wait, let me copy this back. Right, so we have this is part of the this sets the UV, right? So this is from SketchUp pixels. So GLM vec3. Edge 1 is triangle. Do you have a V0? Yeah. So this triangle dot 2 minus triangle dot 1, and then GLM vec3 VP1 is intersection point minus triangle dot 1. Wait, what? Oh, right. So this should be get verts. and then GLM vec3 edge 1 is GLM cross, and that was edge 1 and VP1, and then float U is oh, so this was C. So C dot length. Right. So what does this do? I think this just returns 3. Yeah. So no, it's GLM distance, I think. No, it's the can I just do C? Wasn't there a length? Or does this return simply 3? Yeah, no, there is a GLM length. However, this gives us the, it should be distance, right? No. Oh no, it's length. Okay. Divided by area, and the area, where does scratch the pixel calculate the area? Right. Oh, we have the plane normal already. Right, so let's copy this as well. So GLM vec3 GLM cross v0 v1 v0 v2. But this should simply be the normal that we can, but we already have the normal. However, apparently we don't need to normalize. Oh, right, because the length. That's what I'm hesitant about, if that is actually a problem. But I think it is, if we normalize it. However, I first want to get this working, then we can worry about optimization. And this should just be divided by 2.f, right? And this is GLM dot. No, we don't need to do the intersection calculation because we already know it intersects. Because that's the entire point of this. GLM cross. What was it? Edge 2? Yeah. Edge 2 VP2. Float V. We don't have. Oh, that's the intersection point. And this is triangles get vert. Oh. This is 0. This is 2. And this is 2 as well. So that correct, 0, 2, 2, right. So then we have the UV coordinates. And then we can simply say, so we have a uint 80 pixel array is material this instead of a name. So if material dot get text, if material can I not simply say query the texture? I should be able to. If texture that does not equal null pointer, how does that? Let's include material as well. Core slash material. No, I don't want main. Material dot texture, right? Do I still need this include? Yeah, okay, right, so I didn't know about it. So if that doesn't equal null pointer, yeah, and else return 1.f, 1.f, 1.f. Cool. Unit pointers is material. This is texture equals material dot texture dot get texture, and then we have a glm ifec2 texture size. Oh yeah, this is a const. Texture size equals material dot texture dot get size. Cool. So now we simply want to have an int u, so int our no, I think we can just do simply and then we want a const uint at. This is the pointer, and this is equal to texture, then u so wait, UV coordinates. UV coordinates, right? So V is the vertical, right? Yeah. So it's V times I times texture size dot x plus u times texture size dot x, right? Because what this is going to do, and then we need to cast this to an int. And not v, we need to cast this to an int, and same here. Right, so this will give us the UV coordinates, right? Because what we're basically doing, we're saying we want to multiply v by the texture size dot x, so that will give us the horizontal row. Oh, and this should be multiplied by 3. No, this should be so we need a un32t channels equals material dot texture dot get channels. I don't have that. Cool. So texture in 32t get channels. And then this return dot channels. So that is times As an int32t, I said. Int32t, or I found out, and that is get channels. Then multiplied by channels, and same here. Oh, times channels. So I think this should give us an actual pointer. And we want to return this index should actually be equal to this. And then we want to return simply a vec3, so a glm uvec3 of texture dot index comma texture dot index plus 1 and a texture dot index plus 2. And I missed a comma here. So now we should have the UV coordinates. So that in the Raytracer, we want to simply say, hey, Raytracer.cpp. So the apply shading takes in the material and the hit point. Okay. But it doesn't take in the model, does it? No, it takes in the triangle. That's kind of a pain. Okay. We could pass in the model as well. I think for now we can simply do that. Const RT model reference. No, you know what I think is better actually, instead of having this in the model, just moving this into the material. Right. So now this should be material. And then this. But then I don't need this anymore. I only need the intersection point and the triangle. So we can simply say texture here. And texture. Oh, and this is a this return type. Why do we not know about this? Oh, right, yeah, we named this a bit unfortunate, right? So this is text pointer. Yeah, cool. So now we have it on the material itself. What I think isn't quite the correct place, but it's better. So then we can simply say, hey, the base color, and that is times the material dot Yeah, I didn't mark this as const, did I? No. Right. So that needs to be marked as const. And then in the Raytracer, I can do material like get texture, hit points, triangle. And then I need to dereference this because it passed in as a pointer. Right, and this shouldn't be a U effect, this should be a GLM, just a vec3. It is a GLM vec3 when we read it, sorry, a U vec3 when we read it, but we should cast it to a vec3 when we actually read it. So this should be cast to a float, and that should be done for the rest as well. Right. So if we add static cost, static cost, static cost, we don't need this else. Indeed, we can just return. Yeah, we can just return 111 in case we do this, and then in the Raytracer. Yeah, no, I think that's everything we need. So if we now run in release, fingers crossed, we have a texture. Okay. Not quite. Right, so this needs an error conversion. Oh, we can cast this to EN32T instead. Oh, right, this needs to be out of the model now. Oops, my bad. Okay, it builds. Cool. Get rid of the breakpoint. And we have a model that... Oh! Yeah, of course. So we want to set the... no, we don't want to set this. We want to set it to... no, we don't want to set this to rep material. We want to say this equal to cow1 dot model data dot loaded material. Right. So it's the, we want to set the active material as the loaded in material, what we got from the model. Not quite what I was hoping for, but it doesn't crash, so that's something. But this is debuggable, right? So material, material, right. So let's see what kind of index we're getting. Oh, I might know why. Right, so in the Obj Loader, right, we're moving along with 3, yeah, and they shouldn't be Y, they should be because we're doing this because a triangle has 3. No, so this is vertices. Yeah, so Y is basically like, hey, we have 3 vertices, so no, this is still correct. What am I talking about? No, this is fine because each triangle has 3 vertices. Nothing changes there. All right, let's put a breakpoint. It's a material dot. There. Oh yeah, it's still built in BVH, isn't it? Yeah, I was about to say. Come on, BVH build faster than like once in a millennium. So UMV seem reasonable. So the index is like 2 something something, right? Because it's V times texture size dot x, what is 1024, times the number of channels, what is 3. So this should be equal to like 2048, sure. And this is a very small number, so this is equal to 8 point something. Okay. So this gives us a... Yeah, this should be fine. Is this anything else than text pointer? I want to add to watch, and I want to inspect the text pointer, and I want to inspect the first 3000 elements. Are these all? No, these are all different values, right? So this is... These do actually have valid data. Because this isn't just black, right? Oh! You know what's pure black? These are between 0 and 255. So this is 5 by 255.f. Yeah, right. So it's basically an overflow because we're treating the values between 0 and 1. However, we're setting it like multiplying by 100 something. What is way too much, obviously. So we need to divide them by 255 to get a more accurate value. I really hope that would have done the trick, you know, but a bit much to ask for. However, we can debug in... we can debug this, and then we put a... Right. Breakpoint there. So I want a glm vec3 text color, and this is equal to this, right? And this then times text color. Then we need to let the BVH be built. That's going to take a while. So maybe the base color is simply set wrong. Because what if the base color is like 0, right? And even if you then multiply by a big value, it's going to simply be garbage data. But man, the difference between release and debug is massive. Right, text color, there we go. That looks Perfect. Base color. Oh, yeah, this is 000. That's a shame. Okay. However, we can now see why this is 0. So in here, right. So this is equal to 000. I am guessing. Yeah, we said it. So the diffuse is simple to 0, but what other values do we have in here? Transmittance is 111. Right. So apparently, this material doesn't have it doesn't have a diffuse color. It simply sets the diffuse to 000. What would be fine. However, that's wrong in our case. But I don't want to fix it here because that doesn't make sense. Instead, I'm going to go into the main and say, hey, cal1 dot material dot base color is equal to 1.f, 1.f, 1.f. Right. Oh, and I see an issue here though. In the model, they shouldn't have a sharp pointer. They should have a just a material, right? They should have a copy. So cal1 dot material. Wait, why do I not have... I have a material. What are you complaining about? Oh, I do need... Oh, right, no, I still need the dash. And then I need to dereference this, right? Sure. Is that the only errors? Let's recompile and see what this does. Oh, it's the %, right? And then dereference this. And now we should have the thing, right? So there should be a collective of materials, but each object should have a copy of the material. Yeah. So now the base color is 111, text color is this. Cool. There we go. We have something that looks like a potato. It has colors, I suppose. Although it's white. What doesn't really make me happy, but it's progress. Right, so base color is 1111. And text color is... ships, I can't. This won't run. Let's see if we run this in debug, we can see what kind of value we're ending up with. Because it might simply be white because of a overflow. What I'm expecting it to be. However, release doesn't always make it easy to debug because a lot of values get striped away from the compiler, so you can't actually view them. And debug doesn't do that. What makes a huge difference? I kind of like that in the webcam, right? There are the two open ones and then one closed blinds, what gives a bit of a weird view. Right, there we go. It finally ran. So the text color is currently 0.42. So what does this end up as? Right, it ends up basically being black. Why is this? Why does it... Right, let me run this. Oh, that's actually beautiful. So it's really gray instead of the like yellowish color that it should be, right? And it's not like the object is unlit, because if it was unlit, it would have been black, right? Not gray. So let me just step through this. So current light color is, yeah, so let me find a color picker. So it's calculator, any calculator. Let me see, so that is 0.42, 0.427 times 255. That's 100, 109. 109, 109, and 109. What is gray? Okay. So I'm reading a gray texture from the potato. Okay. So in that case, it might actually be correct. Oh. You know what I'm thinking? Right, so let me open my main display. This is the texture that we're reading. You know what I think we're sampling from? This position. Right. If we're just sampling from like one of these regions, we're never going to get the texture. So there might be something wrong with the UV coordinates, or there might be something else wrong. But we can figure that out. So we get the texture, right? So the get texture text in the intersection point and the triangle. So how much is the... I want to go in the get texture. Like, what kind of values are we producing here? So this is the normal calculated by this. However, what is the normal that we have from the triangle? So this is negative, positive, positive. Is it the same values? What if I don't actually have to calculate this again? Right, what if I could just do m.normal, or just triangle dot get normal divided by 2. No, that doesn't make sense, because it's not really the normal here that we're calculating, is it? Ah, ships, I completely stopped the debugger. That's a shame. Now I have to wait for the BVH to rebuild. Let me double check the Obj Loader while it's busy. So this is going correct, right? So we Yeah, texture coord index plus 0 plus 1, sure. And then we pass in y. Yeah, that should be fine. Then in the material. So I'm curious why we're only getting like the gray area, right? So maybe one of the things I'm thinking that could potentially be happening is that the UV coordinates are calculated wrong and we're getting like weird values that are way too low. Or wait, could it be? Oh, I think my index is wrong because V. Right, no, we're sampling it wrong. So the index, it's V. Right, no, we're definitely doing this wrong. So it's V times the texture size dot x times 3. Yeah. But this should also be plus. No, okay, right. So we have, no, we're doing, I see we're calculating this wrong, right? So we're basically only sampling from the first 2 lines or so, but we should be sampling from the entire image. So the calculation is wrong. I'm calculating the 2D array to a 1D array wrong. So it's in row is V. Sorry, so float row is equal to V times texture size dot y. So the row is so this is the row that we're on. Yeah, look at the row, and then we multiply the row with texture size dot x, right? Because if we have a pixel array, right? So for each row, we need to offset with the number of x pixels that we have. So I think this should be, although we can just, I think we can just move this in here and not deal with this temporary variable. I think this should give us the actual texture now. Or it might crash because I did a Stack Overflow. Or not Stack Overflow, array out of bounds. No, that did something completely wrong. Okay. 2D array to 1D array. Width times row plus column. Why is this not working? I was really hoping this would work. Let's debug again. Yeah, it's not gonna run in debug. What's a shame. Not in release. So the formula should be simply width times row plus column. However, we're dealing with texture coordinates, what makes this a bit more annoying. But it could still be that I simply did the formula wrong. Or I'm gonna just put a breakpoint here, see the value, and then we're gonna fix this. So this could be fine. Honestly, I don't know. Right. Let's put another breakpoint here and make this a bit easier, right? So the float row, float column. Right, so the row is equal to u times, yeah, that's equal to this, right? Because the UV coordinates are between 0 and 1. However, we need to get them between 0 and the image width. So that's this. So the column is v times texture size dot y. And then to go from a 2D array to a 1D array, it would be get this, and then we would need this will give us the column. To get the actual index, right, we would need to do x, so that would be row, yeah, times channels times texture size dot y plus column times channels. Yeah. This should work. No. Oh, and this would be static cast un 32t. And then bracket. It's still gray. It's even worse than before. I think we're sampling completely wrong from this. Because the only way we'd be getting that, like, those values, right, is if it's if I go back to my main display, right? So it would be sampling from like one of these two regions if it's gray. Otherwise it would get the brown colors, I think. So what is the... Can we breakpoint this? No. This is actually a shame. Why is... Did I mess up this basic math thing? From into float... I don't think that should matter, but... I mean, and let's run it in debug while we're at it. That way we can actually see these values. It's going to take a while for it to start up. However, then we can debug these values. That's I think the biggest issue with this Raytracer currently is the long time for the BVH. Oh, it's best out of Visual Studio. So sorry, the biggest issue I think currently with the Raytracer is that the BVH on debug takes forever to build. However, once it's built, we have decent performance even on debug. So I'm talking about like 34 frames per second, right? And on release, this is much better. So give it a second to build the potato, the BVH for it. And then hopefully we should see why this is wrong. Did I put breakpoint down? No, I did not. I think it's almost done. Cool, it's done. So U is that and V is this. So it's row 4 point something, what I'm willing to believe, and this is row 686, right? Okay. So what is the index? That's this, and can I see this value? It's gray. What would be impossible, right? So that would be, so set row 4.5, right? So let me get the main display. Oh, could that actually be gray? It might be. Right, there on the very edge I think it's gray as well. So let's skip ahead one more and see if we can get a different V that's a bit further. Huh. Could I simply have the case being that, right, I can put a conditional breakpoint. So let's put a breakpoint where row is greater than let's say 50 pixels, right? Did this, yeah, and then continue. This is going to be quite slow, however it should hopefully breakpoint. Because what I'm expecting now to be the case is that the UV coordinates are simply calculated wrong. Because V seems to be correct, however, U seems to be incorrect. Because we're never getting like above... yeah, like U is always really, really tiny. Right, so let me see the triangle here. And what kind of texture coordinates are we dealing here with? So these are like big values, right? Yeah, these are like, they should be somewhere around the... Right, I think we're simply calculating them wrong. Calculate UV on a triangle. So we're definitely calculating the barocentric coordinates wrong, for sure. But this is fixable. So we need, yeah, I'm looking for Wikipedia. Hopefully that can help me with calculating the barycenter coordinates. Right. So UV, can you tell me how to calculate UV? Calculate barycenter coordinates triangle. Right, so this is apparently a better way to calculate the right, okay, I found something cool. Let's try this formula. So instead of this massive thing, right, we have this thing. So this is GLM vec3 v0, and that's, yeah, so that's triangle dot get vertices, get verts dot 1, and this is 0, and this was C, so that's 2 minus A is 0, and this is intersect point minus let's close this. This was A, so that's 0. So this is GLM dot float. Let's see if this magically gives us our UV coordinates. I'm hoping it would, because this is from Real-Time Collision Detection, a book that I found on the internet. Oh. Okay, that's fine. Right. We can do GLM clamp. GLM clamp. No, sorry. We would want to clamp the UV coordinates. GLM clamp. And then 0.1. And then same for this one. Because it could be that the barycenter coordinates are just too big, like 1.1 something, right? Because floating point inaccuracy, and that could cause an array out of bounds index. This is producing some different funky results. But there's something weird with the colors. However, this seems to be definitely better. Right, so what is the... That's such a shame. Right, so we got to run this in debug again. So I'm thinking that this is wrong again. So this is row times channels times texture size dot x. No, sorry. So this is just row times channels plus column times channels times texture size dot y. I think this should fix it. I think we were calculating to the array wrong, simply. No, okay, that wasn't the issue. But there's some interesting stuff going on there. Like, some really interesting stuff. Yeah, it's time for the debugger. One of the things I could imagine is happening is I copied the line wrong, so I filled in the wrong values, right? So v0 is b minus a, so 1 minus 0. v1 is 2 minus 0. v2 is intersect point minus 0, right? The rest is all the same. Right, let's give it a while to calculate the PVH. And I think it's almost done, because I think it takes about a minute to calculate on debug. Holy. Right, so U, V, those are reasonable values. So row is 400 something, column is 200. So that would be in the image somewhere, not in a gray section. Okay. So what does this return? Text color. Right, that's not gray. That's everything but gray. Right, let me see what kind of value this is. So I need a color picker. So that was 0.27. At 0.27, 0.48. And text color 0.36. This is annoying. Oh, I put them in the wrong thing. Okay. Copy value. Text color. Y copy value. And copy Z value. And then plot this in the thing, and it produces not a number. Absolutely 0.27. Stupid tool. 0.48. Oh, right. Right, no, I'm understanding the tool. I just put the data in wrong. 0.27, comma 0.48, comma 0.36. No. Right, that's like a greenish color, apparently. What could be color, right? Is it might be like a greenish color, like here, or maybe like this one, like a color here, kind of. That might be kind of greenish. Right. So the material.h. So index, index plus 1, and index plus 2. That should be fine. Let's put another one, right? Index. So it's 89,000. Sorry, no, 891,000, yeah. Right, no, sorry, this should be this. So this is row was 400 something, yeah. So that's in reality the index at this position, because we need to multiply by 3 for every for everything, right? Oh, do I need to multiply by? So the column here. Oh, it's a square texture. Should be fine. I think we're simply sampling this wrong. I did have an in my old Raytracer I had a sampling, something to sample from an image. Sphere. I had a get color somewhere. Right, get UV color. So what did this do? It clamped the UV between 0 and 1. Right. Let me copy this result, this code. So that is texture size dot x, and this is glm clamp. Texture size dot x. This is texture size dot y. And then glm clamp. In my texture size dot y. And this is the uint 8t color pointer, and this is texture. Oh, sorry, this is just texture pointer. Texture pointer. So that's y times texture size dot x times channels times channels, and then we want to return this. What is the color pointer? No, sorry, it should be texture. No, texture pointer. Sorry. As a const, right? Wait, why does this not? Should be fine. Oh, and this is the address of, right? And then this is color pointer, dereference, dereference, dereference. Right. And then we return this. And hopefully this should be everything we need to do. If this gives us, I fingers crossed this gives us the, no it doesn't. It gives us the grey one again. Why does this give us the grey one again? That's such a disappointment. Oh, maybe I know why. Yeah. So this is not clamping between floats. This is a integer clamp. Right, no, so we don't want to do this. Right, because this clamp would mess up things massively. Right, we're getting a stack overflow now. That's sweet. Yeah, you can do a lot with potatoes. Potatoes are like the best thing ever. We can actually clamp this. glm. So x equals glm clamp. X 0 and text size dot x. And then we set y equal to clamp between these two values, right? So that's okay. So we clamp this to make sure it's not within the outside of the bounds. So it still gives us the gray effect. Okay. Yeah, this is such a shame. It's such a shame release can't really debug, because that would have made life like 20 times better. Mainly because the BVH just take forever to build. Wait, potato fricandel, I never heard that one. That's a new one, Nico. Why? Okay, there we go. Now the console's fixed. Kinda. I didn't expect the textures to actually give me that much headache, because I know last time I worked on textures, so on my old Raytracer, this was actually one of the like easiest things to implement. However, the UV coordinates now look correct. The sampling, however, looks wrong. Oh, those sound good actually. That does actually sound really good. Right, so x is 264 and y is 166. So in the image that would be, let me put my main display back. Right. So in the image that would be like somewhere around here, right? I'm thinking. I don't have the exact measure to count. All right, I could actually open the image in Paint. paint, file open. Right, and then I can put paint on in here. Yeah, there we go. So I said x is equal to 264, 166. So 260. So that would be around here, right? Somewhere in this region that we're intersecting it. So that shouldn't give us a. It should be a decent value. So what does this return for color? Yeah, come on. So text color here is now, it's gray. How can it be gray? It's the damn gray value again. Because that makes no sense, right? Because the X and Y are 264. You know, I could do the color picker, right? So 264. Let's zoom in further. Right, so 264. And 166. Yeah, it's a brown color. Right. I think I got the correct pixel, but there's no pixel here. Like, we can clearly see that's gray. So we're sampling wrong. Guaranteed. So let me think about this, right? So Y, so Y times the texture size.x times the number of channels. So this is for each row, how many pixels on the x-axis we have. So we have 3 channels because it's RGB, right? So in the pixel array there are 3 numbers. So for each pixel we need to move 3 numbers along. And then we need to do that the texture size.x times. So this should be equal to 3072, right? Yeah, because it's 1024 times 3. Then Y is 166. So that should be equal to this, sure. And then the X is equal to this. So how can this still give us a wrong value? So it's 123. What would be... Can I see what this is equal to with hovering over it? So 109. And so it's 109, 109, and 109. Interesting, but color pointer is 123. Oh, wait a second. No, wait. We're sampling wrong. We're completely sampling wrong. How did I not notice this? It's color pointer dot 0, and it's color pointer dot 0, and color pointer dot one. So let's call it. Right, no, it's so that's +2. Yeah, I did something really, like, actually really stupid. So what I did, I sampled the array of pixels with the pixel that we calculated. So I was doing some weird math that made, like, actually no sense. However, now I am pretty sure that we're getting the color now. Oh, and then this should be like this, right? Yeah. So I'm like 99% sure that now we have the correct color. But yeah, sometimes you make, like, mistakes that are just really stupid. So what? I mean, I call that progress. It's not perfect, but I'm seeing different colors. Oh wait, shit. Oops, my bad. Sorry. I forgot to close paint. Or I forgot to change it on stream. Right. So let me make this a bit bigger, so it's easier to see. Right. So we're now seeing different colors. Right. My bad. Sorry for that. Now we're seeing different colors. However, this kind of looks like a sampling error because it's like one of those weird patterns, right? I mean, we're only dealing with sampling errors, but you know. I'm at least seeing different colors than... yeah, I'm almost there, Xyphon. Almost there. I just need to figure out why it's doing this wrong, and then we got this. Right, so we're getting the color pointer here. That is the address of the texture pointer at index y times texture size dot x times the number of channels plus x times the number of channels. That should be correct. And then to get the actual color, it's the color pointer divided by 255 for the R, then +1 for the B, and plus that for the right. Could this still be reading the wrong value? Let me just debug this, debug breakpointed, and see if the if we now hover over it, it gives us different values than 109, 109, and 109. What was doing before. Oh, and I made this. I am such a bad streamer. Yeah, now I moved the right. Now it's not blocking the entire programming window, but it did before. Sorry. So, waiting for the PVH to build. What takes like about 5 minutes. No, it doesn't, but it takes way longer than I really would like to. But at least it makes the actual model renderable in real time. Right, there we go. So, color pointer, this is 123, okay. This is 88. And this is 58. That seems good. So step over, yeah, good. So text color is now this value. Okay. And what kind of color would that be? Text color, text color, text color. Wait, in my Raytracer, right? In the main, did I set up the lights to actually... Yeah, I did set them up to be full white lights. Okay. Because I was considering, what if the lights were only red channel? So that could explain the grayness, but it's clearly not doing that. So why is it only getting the red? Am I sampling wrong? No, as in, no. I mean, I'm kind of curious why it's only getting like a reddish hue, right? Instead of the... let me get paint back. So it's getting... I don't know how it's getting the red hue. If you look in the image, right? Yeah, this drawing, yeah, right. So how it's getting that red pattern, that's kind of intriguing me. So it's the this red pattern, right, that we can see here. But it's still gray, but then with the red pattern. Oh, no, I put this wrong. Right, put this back, right. So y times texture size dot x times channels, yeah, plus x times channels. Yeah. There is another formula, what I think should just provide the same result, right? And that would be x times texture size dot y times channels plus y times channels. It's giving a different result. Wait. Text, so that is equal to text pointer plus this, right? Interesting. This is so trippy. Like this effect is so weird. However, I could do this instead of color pointer. I can just do int index, and that's equal to just this, and then I don't do color pointer. I do texture pointer. No, texture pointer dot index. I think this is a bit more readable. Texture pointer dot index plus 1 and texture pointer dot index plus 2. So these are U and AT pointers. Yeah, they are. Oh, why are we? Oh, yeah, I should comment these out. So we're still getting the same result, right? Okay. So there is something else I want to try. So we simply return. We're copying this line. However, we're only extracting the red channel this time. And see what happens then. Right, very interesting. Okay. So say now I only extract the blue channel. Why does this not? Oh. I think this should be good, just like this. So now we shouldn't be able to get any red. Because we simply don't, the texture now doesn't return red. But we are getting red. No, wait. RG. Yeah, sorry, this is green. Right. Okay. Interesting. So what if I just return, just say it's white, the potato. All right, so this looks fine. Okay, what if instead the UV coordinates are wrong? So this part is, we're actually doing everything correct, however we're simply reading the wrong UV coordinates. So we're reading them from this place. So the texture coordinates is the attrib.textcoords 2, yeah, plus 0 plus 1, sure. Texture coords push back, right? And this is texture coords dot 1, I plus 1, I plus 2. That should be fine as well. And just to be sure, does the Right, I'm kind of curious if with Paint 3D I have the ability to open a OBJ file, and it will give me the texture as well. Oh. Because what if it's actually everything is going correct, but this model simply has problems? That could be the case as well. Potato.obj. Asset potato. So it's trying to open the file, but it's not having too much luck there, it seems. Paint 3D is not happy with it. What is a shame. I'm trying to find another viewer that potentially has more support. Okay, yeah, no, I found a viewer that supports it. Right, so let me set this up for the stream. Right, so main display, there we go. So this is the potato model that we're trying to load in, right? So the model isn't broken because we're actually able to view this here. So there is actually something wrong here. That's a shame. Right. I'd really hope that wasn't the case. Paint 3D is hopeless. So is 3D viewer. Just do OBJ textures. How weak. That's correct. Oh, you know what I do have? I have in the texture. When I loaded in verse or flip vertically. What if that's wrong? Because my old Raytracer had it, but what if I actually don't need it here? And because the image is flipped, we're getting garbage data. And of course, I do need to fix then the thing in the material. Because we're returning the 111 line. It should be the actual calculation. Come on, fingers crossed. No, that's literally the exact same. Okay. I am wondering something. If I multiply by 4, do I magically get a texture now? I swear if I do, I'm actually gonna murder somebody. Well, I'm not, but okay, no, I don't. Okay. Wait, what? This crashes there. Access, yeah, okay. So the index is way too big there. So I was wondering maybe the number of channels is secretly RGBA, and that messes up somewhere. But it isn't. So it's definitely 3 then. Okay. So in the texture.h, right? So this returns a unsigned. So stbi load returns, yeah, an unsigned char. Sup, Yessie? How you doing, man? I'm doing good. I'm almost actually done getting the potato textured. However, I'm stuck on something stupid. Yeah, no, I'm trying to give the potato a texture. Right. Pixel, right? Yeah, sure. I mean, at this point, I really would love Bytes to cooperate with me, because they really don't at the moment. Right. Right. Let me show you what the issues I've been running into. Right. So if we run this, we get this beauty, this rotating potato. However, we can clearly see that this does not have a potato skin. It has a everything but a potato skin, I would call it. Yeah, it's very burnt, but you know, I would love to have the non-burnt version, honestly. So I've been trying to figure out why that is happening. So I can show you what I'm basically doing, right? So when I load in an image, I'm using a library called stbi, and I basically just pass in the file path, x and y, and these channels. And these are passed by reference, so these get set by the function. And then it just stores it in an array of unsigned chars, right? Then in the material, I say, hey, I want to calculate the UV coordinates. And these seem to be working fine, I think. So this is just UV calculations. So these give me a value, like an actual reasonable value on the sampling. Then I get some info here, the texture pointer, the texture size, and the number of channels. And then the actual x position is the u coordinates times wait a second. Wait a damn minute. So this gives me UV coordinates based on the triangle, right? But the triangle is UV mapped. So I just realized this doesn't take into account the UV coordinates. So this would be more your weights, right? So you would actually pass in UV coordinates. So these don't make sense. So wait a second. So this is the no, I think I actually know what's wrong now. So these give me the UV coordinate of the triangle. However, the triangle itself has UV coordinates. So I basically have a problem there. So I think this basically gives me the UV based on the triangle if it was 0 and 1. However, I think I still need to multiply them somewhere else, right? This source lied to me. Yeah, right. So this UV is based on the triangle. It's not based off the actual thing. What was passed in. So how do I multiply this with okay. No, I actually know why this is wrong. I just don't know how to fix it. Yeah, right. So wait, let me open Paint and explain what's going on. So Paint. There we go. Right. So this is a triangle, right? Or imagine this is a square. UV coordinates are basically a point. Wait, I need to be a bigger line and in black, right? So this is 0, 1, 1. No, sorry. Yeah, 1. So this is axis, right? And if you have UV coordinates, say 5.0, 5.0, you would sample this pixel. However, each triangle that you have here has its own UV coordinates. So it says, oh, this vertex is in reality 0.3. So this is 0.3, comma 0.4. This is 0.4, 0.5, and this is 0.2, 0.3, right? So any point that you any point in here, so if you hit here on the triangle, it's based on these points where it hits, where the actual thing on the real texture would be. So if you hit there on the triangle, it might actually be this value on the actual map. Yeah. And with a sphere, this is quite simple, but with triangles, it's a bit harder. Right, so triangles, barycentric coordinates to local UV space. Right. Oh. No, I think I know, right. So this is the UV based on so the real UV would be something else. Right, so let me see if I can explain barycentric coordinates. I don't quite know them as either, right? What they are, but they're important. Right, so if I go back to my main display, right, get rid of paint, right. So we have this point, but we still somehow need to get from this point to somewhere else. I have actually no clue what I'm doing, by the way. I've run into something that I'm actually kind of clueless about. I'm really rambling on, but I don't know what to do. So these are still values between 0 and 1. Okay, what if oh, wait a second, right, so what if I do, so V is equal to triangle dot get verts dot 0, no, go from UV coordinates to texture map. Right, so what is, I think it's called UV Unwrapping. Yeah. Yeah, I don't know what I need either, man. So it's quite hard. Right. 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 Sorry for my silence, right? I'm just trying to think. Because this would be basically the UV point on the triangle. However, we need to go from the UVV on the triangle to the actual thing, right? So barycentric coordinates to UV. Does this help? Oh, okay. Okay, wait. I think I got it. Maybe. So v is actually equal to triangles triangle.get verts dot 0. Sorry, one. So this is u is equal times u. Why is this complaining? No, never mind. P0. So PUV. All right. Right. Right, so this would be, this gives me weights. Right, so this would be, okay. So I found a thing from Houdini. What is some software that, oh shit, so I closed the browser. Right, I feel this is gonna help me, right? So in the main display, right? So it's highlighted here in yellow, right? The triangle parametric space in Houdini have vertexes 0, 0 at the origin, and vertex 1 at the u-axis, blah, 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 vertex 2. Yeah. So these are equivalent to 2 barycentric coordinates, right? Of the triangle, namely the barycentric coordinates associated with vertex 1 and 2. The barycentric coordinates are associated with vertex 0 is 1 minus u times v. These give the 3 linear interpolation weights for the vertices. E.g. P is u comma v. B, so P0 would be the x intersection, y intersection, and z intersection, I think. Right. So that would give us, yeah. No. This looks helpful, but in reality it doesn't solve my problem. So we have a intersection point here, right? We know the barycentric coordinates of that intersection point based off u. And this question pixel has something on this as well. Scratch the pixel. Scratch the pixel barycentric. Oh, I think we're close but missing a crucial step. Right. So, yeah, right. So we have this one, right? So we have the u, v, and w component, and p, the actual point is this formula. So this would be the texture chords, right? And p would be your final. Oh, okay. Right. I think we can solve this now. So float at p is equal to dot triangle or no triangle dot get texture chords dot 0 times U plus no, sorry, this is a glambvec2. And this is times V, and then plus, and this times W. And this is plus, right? So this gives us the actual UV coordinates. And then instead of multiplying by U, we do P dot X and P dot Y. Yeah. I am 60% certain this will work. Maybe more, maybe less. I said, oh wait, no, I'm seeing some things in there. Because I can see some like brown in there. Like you can see kind of like in this spot, right? Let me make this a bit bigger so it's easier to see. So in here, right, like in this point, oh, my mouse is not showing. Cool. Oh no, it is. In this spot, we can see like some brownish. Like there's definitely some color now. Times W, right? Oh, maybe I'm simply... So it's U V W. Oh, no, wait. This is multiplying wrong. So this is W. And this is U. Let's try this. Maybe the order was simply wrong. Because I'm looking at the scratch pixel code. No, this doesn't seem really any better. This kind of looks the same. So according to this, right? So the P color is the triangle color. Oh. No, okay, wait. No, we're sampling wrong again. We're close, right? So we get the three colors at the pixels, I think, and then right now I think I can solve this with a bit of sleep, or at least a bit of a break, because I've been streaming for what is like over 4 hours now, and I had to work in 15 minutes, so I need to get changed like quickly. But yeah, but I think I'm close. Because now we get the mix ratio between them. Wait, there's one more thing I want to try. Swapping these around. If that doesn't work, I'm stopping. I mean, I have to stop anyway, but this is one more thing I want to try. No, okay, that doesn't work. That was too much to expect. However, I think we're actually getting there. But anyway, Jesse, yeah, thank you very much for joining, and everybody else as well that was here. I'm gonna have to stop streaming because I have to had to work, I'm afraid. I would love to continue with this because I'm so close, I can feel it. But yeah, I really have to work. What is a shame, but yeah. But yeah, thank you all for watching and have a good day. See you, everybody.